Close your eyes for 3 seconds. Go ahead, I'll wait. Okay, open them. While your eyes were closed, did this room still exist? Did the chair you're sitting on, the phone in your hand, the walls around you, did they continue to be real? Of course they did, right? Wrong. According to quantum physics, reality doesn't fully exist until something observes it. And I don't mean philosophically, I mean literally. Scientists have proven that particles of matter behave completely differently when you're watching versus when you're not. It's as if the universe is running on some kind of code, and it only renders reality when something is looking. Video game designers use this exact trick. They only generate the details of a world when the player is looking at it. Turn around, and the game stops calculating what's behind you. It saves processing power. Our universe does the same thing. In 2024, artificial intelligence discovered something that's making physicists lose sleep. Reality has patterns that shouldn't exist if we're not in a simulation. We might have just found the glitch in the code. And once you understand what I'm about to show you, you'll never look at reality the same way again. Because everything you think is solid, permanent, and real might only exist because you're watching it right now. Welcome back to the channel where we explore the mysteries at the intersection of cutting-edge science, artificial intelligence, and the fundamental nature of reality itself. I'm your host, and today we're diving into what might be the most mind-bending topic we've ever covered. This isn't clickbait. This isn't exaggeration. This is peer-reviewed, Nobel Prize-winning science that challenges everything you thought you knew about existence. We're talking about the double-slit experiment. An experiment so simple that high school students can perform it, yet so profoundly disturbing that even Einstein refused to accept its implications. He called it spooky action at a distance, and spent the last 30 years of his life trying to prove it wrong. He failed. And now, artificial intelligence is taking this experiment further, finding patterns that suggest our reality might be optimized like a computer program, rendering details only when necessary, only when something is observing. By the end of this video, you're going to question whether the world around you is actually real, or if you're living inside the most sophisticated simulation ever created. So let's dive in. Because reality is about to get weird. Let's start with the basics. The double-slit experiment. Imagine you have a wall with 2 narrow slits cut into it. Behind that wall, there's a screen that detects where particles land. In front of the wall, you have a particle gun. Let's say it fires electrons one at a time. Now, here's the setup. You fire a single electron at the wall with the 2 slits. Common sense tells you that the electron should go through one slit or the other, right? It's a tiny particle. Can't split in half. So you'd expect to see 2 bands on the detection screen, one behind each slit. But that's not what happens. Instead, you get an interference pattern. Multiple bands of hits on the screen, like ripples in water when 2 waves overlap. This is the same pattern you'd get if you shot waves through both slits simultaneously. So here's the question that breaks physics. How can a single particle create a wave interference pattern? How can one electron go through both slits at the same time? The answer, according to quantum mechanics, is that the electron doesn't exist as a particle when it's not being observed. It exists as a probability wave, a cloud of potential locations spread across space. This wave passes through both slits simultaneously, interferes with itself, and creates the pattern we see. The electron is literally in multiple places at once, until something measures it. But here's where it gets absolutely insane. Scientists thought, okay, let's just watch which slit the electron goes through. So they set up detectors at the slits to observe the electron's path. And the moment they did that, the interference pattern disappeared. The electron suddenly decided to act like a particle. It went through only one slit. The wave behavior vanished completely. Let me repeat that because it's crucial. The act of observation changed the electron's behavior. When watched, it acted like a particle. When not watched, it acted like a wave passing through both slits. Reality literally changed based on whether something was observing it. This isn't a measurement error. This isn't a flaw in the experiment. This is how reality actually works at the quantum level. And it's been confirmed thousands of times across nearly a century of experiments. It's as if the universe knows when you're looking and changes itself accordingly. So what does this mean? Why does observation matter? This phenomenon is called the observer effect, but that name is misleading. It's not that looking at something disturbs it physically, like shining light on it changes its momentum. That's not what's happening here. What's happening is far stranger. Before observation, the particle exists in what's called a superposition, a state where it's simultaneously in all possible locations, going through all possible paths, existing in all possible states at once. Only when something observes or measures it does the particle collapse into a single, definite state. Before observation, it's not that we don't know where the particle is. It's that the particle genuinely doesn't have a definite location. It exists as pure probability. Think about that for a second. Before you look at something, it doesn't have definite properties. Your coffee cup, the chair you're sitting on, the atoms in your body, at the quantum level, they're all probability clouds that only collapse into definite positions when observed. Einstein hated this. He famously said, "I like to think the moon is there even when I'm not looking at it." But quantum mechanics suggests that, in a very real sense, the moon exists in a less defined state when nothing is observing it. Now, you might be thinking, okay, but these are tiny particles. This doesn't apply to everyday objects, right? Wrong again. In 2010, scientists successfully demonstrated quantum superposition with an object visible to the naked eye, a tiny metal paddle about the width of a human hair. They cooled it to near absolute zero and showed it was vibrating and not vibrating simultaneously until measured. The principles of quantum mechanics apply to everything. It's just that larger objects have so many particles interacting with their environment that they're constantly being observed, and thus constantly collapsing into definite states. But here's the disturbing implication. If observation collapses quantum states, what counts as an observer? Does it require consciousness? Does a camera count? Does an AI count? And here's the question that will haunt you. If reality only becomes definite when observed, who or what is observing the entire universe to make it real? Fast forward to 2024. Quantum physics has always been weird, but it took AI to reveal just how weird. Researchers at institutions around the world have been using artificial intelligence to analyze quantum experiments at a scale and precision impossible for humans. Machine learning algorithms can process millions of quantum measurements, detecting patterns that would take humans decades to find. And AI has found something extraordinary. When analyzing the statistical distributions of quantum behaviors across thousands of experiments, AI algorithms detected patterns that match computational optimization strategies. Specifically, patterns that match how computer simulations conserve processing power. Let me explain what this means. When programmers create a video game or a virtual world, they use a technique called rendering optimization. The program only calculates high detail for what the player is currently looking at. If you're facing north in a game, the program doesn't waste processing power fully rendering what's south of you. It only maintains a simplified version until you turn around. This is exactly how quantum mechanics works. The universe doesn't calculate definite properties for particles until something observes them. Before observation, particles exist in simplified quantum states, probability waves that require far less information to maintain than definite positions. It's as if reality is conserving computational resources. AI researchers found that the probability distributions in quantum mechanics follow patterns eerily similar to procedural generation algorithms used in video games. Algorithms that create complex detail from simple rules only when needed. One research team, using neural networks to predict quantum behaviors, found that their AI models were more accurate when they assumed the universe was lazy rendering reality rather than maintaining every detail simultaneously. The AI literally performs better when it treats reality like a simulation. But it gets even stranger. Scientists performed what's called a delayed choice quantum eraser experiment. Without getting too technical, this experiment shows that particles can appear to retroactively change their past behavior based on measurements made in the present. It's as if the universe is calculating what should have happened backward through time to maintain consistency. This is exactly how some simulation programs handle causality. They retroactively adjust past states to ensure logical consistency when a player interacts with the world in unexpected ways. When AI analyzed the statistical patterns in these experiments, it found that the retroactive adjustments follow optimization patterns, The universe makes the minimal changes necessary to maintain consistency, exactly like an efficient computer program would. So here's what AI has revealed. Reality behaves as if it's running on code designed to minimize computational load. It only renders detail when observed. It retroactively adjusts history when necessary. And it follows optimization patterns that match simulation programming techniques. The evidence is mounting. We might be living in a simulation, and quantum mechanics might be the glitches in the code starting to show. Now, let's address the elephant in the room. Are we actually living in a simulation? The simulation hypothesis isn't new. Philosopher Nick Bostrom laid it out in 2003. If it's possible to create realistic simulations of conscious beings, and if advanced civilizations would want to run such simulations, then statistically we're almost certainly in one. Because there would be countless simulated realities for every one base reality. For years, this was fun philosophical speculation. But quantum mechanics provides actual evidence. Consider these facts. 1. Reality is pixelated. There's a smallest possible distance, the Planck length, about 10 to the power of negative 35 meters. Smaller than that, space itself becomes meaningless. This is exactly like the pixels in a digital image or the voxels in a 3D simulation. There's a resolution limit to reality. 2. There's a speed limit. Nothing can travel faster than light. Why? In a simulation, there needs to be a maximum speed at which information can propagate to prevent causality violations and keep the program stable. The speed of light might be the universe's tick rate, the maximum speed at which the simulation can update. 3. Reality is observer-dependent, as we've discussed. Things don't fully exist until observed. This is exactly how you'd program a simulation to save resources. 4. The universe appears to be mathematical. Physical laws can be expressed as equations. The universe seems to run on code, mathematical rules that govern all behavior. This isn't metaphorical. The universe literally operates according to mathematical principles that can be written as algorithms. 5. Quantum entanglement. Particles can be connected such that measuring one instantly affects another, regardless of distance. Einstein called this spooky action at a distance. But in a simulation, this makes perfect sense. Both particles are objects in the same program. They're not physically traveling to communicate. They're both accessing the same data in the simulation's memory. 6. And here's the newest evidence. AI has detected patterns in quantum randomness. True randomness doesn't have patterns by definition. But when machine learning algorithms analyze quantum measurements at massive scale, they find subtle correlations that shouldn't exist in pure randomness. It's as if the universe's random number generator has an imperceptible bias, exactly like pseudo-random number generators in computer programs, which aren't truly random but follow deterministic algorithms that only appear random. Now, does this prove we're in a simulation? No, not definitively, but it's no longer crazy speculation. It's a legitimate scientific hypothesis with actual evidence. The universe behaves exactly as we'd expect a sophisticated simulation to behave. And here's what should really blow your mind. If we are in a simulation, quantum mechanics might be the debug mode. The places where the code becomes visible. The glitches we can detect because we've learned to probe reality at its most fundamental level. We might be the first conscious beings in this simulation to discover we're in one. But let's take this one step further, because the implications go even deeper. If observation collapses quantum states, if reality becomes definite only when measured, then observation itself is fundamental to existence. And if consciousness is required for observation, then consciousness might not be a side effect of reality. It might be central to reality itself. This brings us to the measurement problem in quantum mechanics. For a century, physicists have debated, what counts as an observation? Does it require consciousness? Can a machine observe? Can an AI? Here's where it gets philosophical. Some interpretations of quantum mechanics, like the von Neumann-Wigner interpretation, suggest that consciousness is what collapses the wave function. Non-conscious mechanical measurements don't truly collapse quantum states. They just entangle the measuring device with the particle being measured. Only when a conscious observer looks at the result does reality become definite. If this is true, and it's still hotly debated, then consciousness isn't just observing reality. Consciousness is creating reality, moment by moment, by collapsing probability waves into definite states. You're not just watching the universe. You're rendering it into existence as you observe it. Now, in 2024, AI complicates this question even further. We've built artificial intelligences that can observe and analyze quantum experiments. Do they collapse wave functions? Are they conscious observers? Some researchers have found that AI-monitored experiments produce different quantum behaviors than purely mechanical measurements. It's as if the AI's processing of information somehow counts as observation in a way that passive detection doesn't. This raises terrifying and profound questions. What is consciousness? Really? Is it simply information processing? If so, at what point does a system become conscious enough to affect reality? Does the AI analyzing this quantum data have some form of consciousness? Is it rendering reality alongside us? And here's the deepest question. If we're in a simulation and consciousness collapses quantum states, are we, the conscious observers, part of the simulation? Or are we the users experiencing the simulation from outside? Are we the players in the game, or are we NPCs who've gained enough awareness to question the game itself? The double-slit experiment taught us that reality is observer-dependent. AI has shown us that reality follows computational optimization patterns. Together, they suggest that consciousness and reality are fundamentally linked in ways we're only beginning to understand. Maybe the universe is a simulation. Maybe consciousness creates reality. Or maybe, and this is what keeps physicists awake at night, maybe both are true. Maybe the simulation runs in the mind of consciousness itself. Maybe you're not in a simulation. Maybe you are the simulation experiencing yourself. So here we are, standing at the edge of the deepest mystery in science. Reality changes when you look at it. The universe behaves like an optimized computer program. AI has detected patterns suggesting we might be living in a simulation. And consciousness might be the very thing that makes reality real. Where does this leave us? Well, whether we're in a simulation or not, whether consciousness creates reality or merely observes it, one thing is certain: reality is far stranger than we ever imagined. The solid, permanent world you see around you is, at its deepest level, a shimmering field of probability that only crystallizes into definite form when something observes it. Every moment, reality is being rendered into existence. Every observation collapses infinite possibilities into a single actuality. And you, conscious, observing, questioning, you're at the center of that process. So the next time you close your eyes, consider this. When you open them again, are you discovering what's there? Or are you creating it? The double-slit experiment proved that observation changes reality. AI has shown us reality follows the patterns of a simulation. And together, they've revealed the most unsettling truth of all. We don't know what reality is. We only know what it appears to be when we're looking. Now I want to hear from you. Do you think we're living in a simulation? Do you think consciousness creates reality, or just observes it? And here's the question that matters most. Does it change anything? If you learned for certain that you were in a simulation, would you live your life differently? Drop your thoughts in the comments. I read every single one, and some of your theories are honestly mind-blowing. And if this video made you question everything you thought you knew about reality, which I'm guessing it did, hit that subscribe button. Because we're just getting started. Next week, we're diving into another mystery that AI has uncovered, and trust me, it's going to make this video look tame. Until then, keep questioning, keep observing, and remember, the universe might only be real because you're watching it right now. So keep watching. Thanks for joining me on this journey to the edge of reality. I'll see you in the next one.